Simple random sample of 35 earthquakes, the mean depth was found to be 9.808 kilometers with a standard deviation of 5.013 kilometers. So our sample data here includes two sample statistics, the sample mean and the sample standard deviation. We're going to construct a 95% confidence interval to estimate the mean depth of all such earthquakes. So in the TI-84 calculator, we would choose option 8, the T interval. In StatCrunch, what I would do here is press Stat. Since we don't know the standard deviation, we're going to use T statistics. This is a one sample, and we have the summary data. So here, the sample mean was 9.808. The sample standard deviation was 5.013. The sample size, we had 35 earthquakes. Here we're constructing a confidence interval at 95%, and I can plot the interval, press compute, and here I have a small window that includes both the lower limit and upper limit for my confidence interval. So there's my 95% confidence interval. My point estimate, in this case, our one number best guess is the sample mean, 9.808. That was actually given. And our margin of error, remember, is how far we move from our point estimate here in the center to one of the endpoints, the upper limit or lower limit. So I can just simply take the upper limit, the 11.53, subtract off the point estimate, 9.808. And that's where I got the 1.722. In part C, suppose that the margin of error is too large. So 1.7 is too large. How large a sample would you suggest in order to reduce the margin of error to no more than 1 kilometer? So here's the formula that we learned. And so at 95% confidence, the Z value is 1.96. Sigma we don't have, but our best guess right now would be somewhere close to the 5.013, so we'll use that. And the margin of error that we want, the M, is 1 kilometer, and so this is what I've calculated. Now, in StatCrunch, you can, if you go to Z statistics, since we're using a Z formula here for our sample size, one sample, choose, given the width, what sample size is required here. So here I'm looking at 95% confidence. The standard deviation that I'm assuming is 5.013. Now the margin of error that I want is 1. Since you go 1 to the left and 1 to the right, the overall width of my interval I want to be 2. Press compute, and I get 97. That's pretty cool. In fact, here, if you would like, you can take this point, and by changing the width that you want, you can estimate what the sample size should be.